So now we are going with 31st. Which one of the following statement is wrong? Which one is wrong? Young modulus for a perfectly rigid body is 0. Just I told you. Young modulus is FL upon A delta L. If object is perfectly rigid, it means by applying any amount of force, you cannot change length. It means for perfectly rigid body, delta L should be 0 and anything upon 0 should be infinity. So how Young modulus of a perfectly rigid body will come 0? So it means wrong statement is first only. It saves your time. Next, a uniform wire of mass m, length L, area of cross section A and Young's modulus y hangs from the ceiling. Its elongation under its own weight will be a very important problem. You will learn one new thing. See, I am taking, it is the roof or ceiling. I am taking one ball, one wire of length L. We want to calculate change in length by its own weight, where its weight will work. Weight is at its center of gravity and it is at center only, center part. Its weight is working here. Weight for full but working at half length L by 2. Weight is for full but working at half of length. We know that what is y? FL upon A delta L. Weight of full, if mass is m, weight should be mg. But not working at this end, so we cannot take initial length, full length. It should be L by 2. A delta L. So what is delta L? In this case, delta L should be 2A y. What we are getting? MGL upon 2AY. So we will go with B. We are going with option B. Next, the compressibility of water is this. If 1 liter is subjected to a pressure this, the decrease in its volume is, we know that what is bulk modulus? Pressure, original volume upon change in volume. What you want to calculate? Change in volume. Decrease in volume means change in volume. It should be P. V. Take this K on other side. It will become 1 upon K. Each and everything is given. The unit of P will cancel the unit of K because pressure and bulk modulus have same unit. In which unit you will take V? You will get delta V. Take care of my statement. If I will take V in cc, then only I will get delta V in cc. P and K both are given in SI units. So I will take them in SI unit, but V I will put in cc. So I will get my answer in less time. What is pressure? Pressure is 4 into 10 to the power 7. Reciprocal of bulk modulus is compressibility. You can see units are reverse only. So I am taking that 6 into 10 to the power minus 10. 1 liter means 1000 cc. A very practical unit you are using in daily life. So I will get delta V in cc. So with which answer I have to go? Number is 24. Now count zeros. Plus 10, 7 and 3 and minus 10 cancel out. So only 24 cc. So I have to go with option B. Next, a stress of 3.18 into 10 to the power 8 Newton per meter square is applied to a steel rod of length 1 meter along its length. Its Young modulus is 2 into 10 to the power 11 Newton per meter square. Then the elongation produced in the rod in mm is, means we have to take care of unit here also. What they are saying, basic formula is simple. Y is equals to FL upon A delta L. In this problem they gave us stress, means F upon A is directly given, L is given. We want to calculate this delta L. So first making my formula, delta L should be this stress which is given into original length upon Y. So first I am using SI units, so I will get in meter. After that I will complete it, change in millimeter, because I know that 1 meter is equals to 1000 millimeter. What is the stress? 3.18 into 10 to the power 8 SI unit. What is length? 1 meter. What is Young's modulus? 2 into 10 to the power 11. So this answer is in meter. So if I will multiply this by 1000, I will get in millimeter 2 into 10 to the power 11 into 1000. Now my answer is in millimeter. 10 to the power 11 and 10 to the power 11, 8 and 3, 11 cancel out. Only you should know the table of 2. 2 ones are 2, 2 5s are 10, 2 9s are 18. So we are going with option D. Next, again very simple problem. No units are there. The stress required to double the length of a wire of Young's modulus Y is. The stress required to double the length of a wire of Young's modulus Y is. What is Y? FL upon A delta L. They are talking about F by A. F by A means stress. L by delta L. First I am making my formula. So what should be stress? Y delta L upon L. If I want to double the length, it means change should be equal to the length, because delta L is final length minus initial length. It is equal to L only. So cancel L with L. What we are getting? Stress should be equal to Y. So we are going with option C. Next, if in a perfectly rigid body, Young's modulus is infinite, good, bulk modulus is 0, same concept is there. If it is perfectly rigid body, change in volume also should be 0, so it should be infinity. So we are not going with A. Young modulus, it should be infinite, not going with B. Young's modulus is infinite and bulk modulus is also infinite. So I am going with C. Concept I explained you. Next, again a very good problem. A rubber rope of length 8 meters is hung from the ceiling of a room. What is the increase in length of the rope due to its own weight? Now density is also given. First I am making my formula. Y is equals to FL divided by A into delta L. I want to calculate increase in length of rope. So I am taking delta L on one side. So I am getting FL upon AY. What is force? Force is its weight. So it should be M into G. Now, what we have to take care of? Length is not given. Again, the wire is hung with the ceiling. Weight is acting at this point. Weight of whole, but acting at this point means weight is acting on a length L by 2. So first I have to put in place of L, L by 2. Mass is not given. So what I have to do with mass? Mass is volume into density, and volume is area of cross section into length. Since it is mass of whole body, whole length, so I am taking L here. Area of cross section into length into density. So in place of mass, we have to write whole L. So we are getting, in place of mass, I am writing area of cross section into length into density. G, L and 2AY all are presented there. So now we can calculate it. Everything is given now. We take care of everything. So now we can calculate delta L. Answers are in millimeter, but first I will get my answer in meter, then I will convert it in millimeter. So A, length is given 8 meter. Area of cross section, it is cancelled out, so no need for this. Length is given 8 meter. So 8 rho 1.5 10 to the power 3 G, I am taking 10 given, again length 8 2 Y 5 into 10 to the power 6. I will get this answer in meter. So by multiplying 10 to the power 3, I am converting my answer now in millimeter. It is the conversion factor. Now what powers are involved? See, this 10 to the power 6, I am cancelling with 3 and 3. 5 into 2, 10, 10 with this 10. So what we are getting? 8 into 8, 64 into 1.5 means 64 and half of 64, 96 millimeter. So I am going with option D. 38. Young's modulus of the wire depends on length, diameter, material, mass. I know, and you also knows this, Young modulus was the proportionality constant, does not depends on the physical quantities which appear there, means M, L, R. It is the property of material only. That's why in every place they are saying Young modulus of steel, Young modulus of brass, not Young modulus of this wire and that wire. Next, two wires of the same material and same length but diameters in the ratio this stretched by the same force. The potential energy per unit volume of the two wires will be in the ratio. First, I will make the formula for potential energy per unit volume. I told you potential energy per unit volume see, I am writing it by E dash. It is given by half stress into strain. Change in length is not given, so we cannot use the strain, but we know that Young modulus is stress upon strain. So I am removing that strain. For that change in length, it is not given. So I am removing strain by stress upon Y. So what I am getting for energy per unit volume? Half stress into stress divided by Y. So what we have to do now? I am writing it stress into stress, stress square. Stress is F upon A. So F square, 2 is there, Y is there, A square. So now first case, E1 dash. I am taking FF, 2 is always 2, YY, AA. What is the second case? They are saying the two wires of same material, same length are stretched by same force. Force is same, material is same, but diameter are in the ratio 1:2. If for second wire diameter is double, means radius is double. If radius is double, pi r square will become 4 times. So area should be 4a. This. What we want to calculate? The potential energy per unit volume of the two wires will be in the ratio, means E1 dash divided by E2 dash we want to calculate. So first writing E1 dash F square upon 2y A square divided by multiplying. So what I am getting? 2y into 16a square upon F square. Cancel this with this, 2y with 2y, a square with a square. What we are getting? 16:1. So going with D option. Next. The Young's modulus of the material of a wire is 2 into 10 to the power 10 Newton per meter square. If the elongation strain is 1%, what they are saying, don't be confused. It is a confusing thing they gave. Elongation strain is 1%, means 1 upon 100 they gave you. Young's modulus, strain has no unit, so unit is not given. 2 into 10 to the power 10 Newton per meter square. We want to calculate energy stored in SI unit means in joule per meter cube. What is formula for energy stored per unit volume? Energy stored per unit volume is given by half stress into strain. Strain is given, stress is not given. Stress we can write Young modulus into strain. So we are using now this formula because Young modulus is stress upon strain. Like previous problem, in that we remove strain. In this problem we have to remove stress. Getting my point? They can do this. So remember this formula. So now it is half y into strain square. So only by putting the values I will get my answer. What is y? It is given in SI unit. 2 into 10 to the power 10. What is strain? 1 upon 100 into 1 upon 100. So what I am getting? I am getting 10 to the power 10 minus 4, 10 to the power 6 joule per meter cube. So going with option A. 41st. 2 raindrops falling through air have radii in the ratio 1:2. They will have terminal velocity in the ratio. I told you in the slides before starting the questions of crash course that terminal velocity is directly proportional to radius square. It means terminal velocity upon radius square, it should be constant. So if initial for one drop I am taking it Vt upon R1 square. For second drop I am taking Vt dash. Radii are in the ratio 1:2. So I have to take 2r for second drop. So what is the ratio of terminal velocity? Vt by Vt dash r square by 4r square. So what I am getting? 1:4. So going with option B, 1:4. Next, water is flowing in a river. If the velocity of a layer at a distance 10 centimeter from the bottom is 20 centimeter per second, we know that layers which are in touch with the bottom, they are stationary. Stuck with the ground molecules attract the water molecules. So layer of ground means bottommost layer, its velocity should be 0. After 10 centimeter, we got 20 centimeter per second. It means velocity gradient it should be 20 minus 0 upon 10. So velocity gradient is 2. It means 2 centimeter per second per centimeter, means with each centimeter change in velocity, it should be 2 centimeter per second. If you go at a height of 40 centimeter, change in velocity should be 40 into 2 centimeter per second. It means 80 centimeter per second. And ground layer has velocity 0. So layer which is at a height of 40 centimeter, its velocity should be 80 centimeter per second. So we are going with D. When the temperature rises increase the viscosity of, what is a change in the viscosity? We want to explain what happens with gases, what will happen with liquids. See, when you are increasing the temperature, molecules of liquid will go away from each other. It means now there is a less attraction. Since force is reducing, means viscosity of liquid is reducing. But root means square speed of gas molecules are directly proportional to square root of temperature. If you increase the temperature, molecule will move very fast. So much collisions are there, so much resistance is there. So velocity of gas will increase, but viscosity of gases will increase due to fast motion of molecules, more collisions, but it will decrease in liquids. So gases increases, liquid decreases, so going with B, 43B. A metallic sphere of mass m falls through glycerine with a terminal velocity v. If we drop a ball of mass 8m in same liquid column, terminal velocity will be only same thing. Terminal velocity is directly proportional to radius square. So only you have to find, means terminal velocity and radius square, this ratio should be constant. If I am taking radius of metallic sphere of mass m is r, so what is m? Mass is volume into density. For 8m, material is same, so radius should be different. I am taking capital R. Dividing this by this, I am getting 8 is equals to r cube upon small r cube. So r is equals to 2r. So radius of big ball is 2 times the radius of small ball. So if in first case terminal velocity was v, radius was r. In second case, if it is v dash, radius is 2r, so it should be 4r squared. Cancel this with this. So what we will get? Terminal velocity should be 4v. So we are going with option B, 4v. Next, the rate of flow of a liquid through a capillary tube of radius r is v, when the pressure difference across the two ends of the capillary is p. If pressure is increased to 3p and radius is reduced to r by 2, then the rate of flow becomes, I told you, what is the formula for rate of flow? Poiseuille's formula. Rate of flow is given by pi p r raised to the power 4 upon 8 eta L. If initially it was this, I am denoting it by any term. We can say rate of flow of water Q. The new rate of flow of water Q dash, it should be what we are doing. Initially it was V. They are saying initially it was V. So now we are taking it V dash. What is V dash in terms of V? We have to calculate V dash in terms of V. Pi is constant. We are making pressure 3 times, means making it 3p. Radius r by 2. So r by 2 raised to the power 4. Liquid is same, eta is same. Length of tube, no change. So I am taking it L. So what extra number we are getting? 3 in numerator. If pressure is increased by 3p, initially it should be increased by 3p, it should be increased to 3p. So change should be, initially it was p, So change of pressure, it should be 2p. If they write that 2, otherwise we will not get any answer. Because term is coming 3, 3 is not in a numerator of any term. So that's why I am removing it. I am changing the question. If pressure is increased to 3p, initially it was p, now it is 3p. So change in pressure is 2p. Actually it is change in pressure difference across the two ends. So change should be 2p. So now it should be 3. That number is 2. Number is 2. And what additional number we are getting? Remaining is v. So 2 raised to the power 4, we will get 16. So you will get 2 8s are 16. So we will get v by 8 because we will get 8 in denominator. So in this case, or make it, if pressure is increased to 2p, increased by 2p. Initially pressure difference was p, it is increased by, we can do this, increased by p, so it will become 2p now. Increased by p, we can do this, increased by p, so it will become now 2p. So we will get option A, otherwise you will get no option. So in this way, we have completed the 5th unit of our crash course. In new slides, we will start 6th unit, and it is thermodynamics. Thank you.